Welcome to the mini test in the lesson 6. Oops, I clicked something. Now let's get the laser pointer and start solving. So first task wanted us to determine what type of the sequence it is and to solve for the next 3 terms. Well, we can see that it's arithmetic because we have a constant difference. So 8 minus 5 is equal to 5 minus 2, while 8 divided by 5 is not equal to 5 divided by 2. Now, the difference is 3. We paste the formula we learned before, or we get it. And then we solve for the 4th, 5th, and 6th term. I'm just going to do them at the same time to save time and help you guys skim through as fast as possible. We take the 4 minus 1, 5 minus 1, and 6 minus 1. We get 2 plus 3 times 3. We get 2 plus 4 times 3. And we get 2 plus 5 times 3, which is 11, 14, and 17 respectively, which gives us arithmetic sequence of 2, 5, 8, 11, 14, 17. Not that complicated at all. Next one, 81, 27, and 9. We take the difference, we see that it's not the same. We take the ratio, we see that it's 3. So ratio is 3, we copy the formula we remember. First term in, ratio in, then put the 4th, 5th, and 6th term, paste in the responding n values. We get fractions, so we get 1/3 to the power of 3 to the power of 4 to the power of 5, which give us fractions of 1 over 27, over 81, and over 243 respectively. But let's write 243 as 81 times 3 to make calculations easier, as technically 81 times 3 is the difference between exponent of 4 and 5, right? So we have 81 divided by 27, 81 divided by 81, and 81 divided by 81. That's also divided by 3. So we can cancel out the common factors. We get 3, 1, and 1/3, which are the next 3 terms. Our answer being the geometric sequence, with next 3 terms being 3, 1, and 1/3. Hopefully this is clear to you guys. Now, again, solve 3 terms and everything. We can see that there's neither constant difference nor the constant ratio, especially because the first 2 terms are the same. So let's see what does change between the terms. Maybe it's a predictable pattern of ratios or differences. So let's see. For difference, where I will be listing the number we add to the individual term above it. So if we add this difference to this term, we get this one. And we only add up. So this difference is added to the second one, not to the 2, not to the first one, only to this one. So it's something like 0 plus 1 gives us 1, 1 plus 1 gives us 2, 2 plus 1 gives us 3, etc. Now, we see something familiar. We add the previous term to the current one to get to the next, as this this is all moved by 1 space to the right, or to the left, however you want to look at it. So adding this one to this one is basically like adding this one to this one. And adding 1 to 2 is like adding this one to 2. And adding 2 to the 3 is like adding this 2 to the 3. So we're adding the previous terms to the current one to get the next one. It could be easier to determine if we had more terms, but since this is all we have, this is one of the fitting patterns called Fibonacci sequence. So our first part of the answer is a Fibonacci sequence. We use the recursive formula for it. We mark the 6th, 7th, and 8th term. How do we know they're there? Because, well, these are the first 5 terms. We added the formulas for each of these terms to show us simpler relations. So instead of n minus 1, n minus 2, we're just going to paste in 5, 4, or 6 and 5, or 7 and 6. Now, we have 2 ways of solving this. One is to solve for x by putting in the 5th and 4th term, then put the 5th and 6th term calculated into 7th one, and then put the calculated 7th one and 6th one into the 8th one. Or, well, this process will take a bit more time. However, it will make sure that you're more precise if you're not versed in doing math. However, there's another way to solve this, which I will use. If you remember how we solved systems of equations, technically this is a system of 3 equations with 3 variables, because 6, 7, and 8 are the 3 variables we need to find out, and we have 5 and 4 that are already given, of course. So I can just color the 6th term orange and paste it in the 7th and the 8th term. So you see these orange parts are pasted in the brackets in their own extended term definitions now. Now we do the same for the 7th term, so I will color all of this with orange and paste it instead of A7. Now we have a now we have a crap ton of brackets, and now that we have placed all of them correctly, we can remove them and solve for the desired terms. So I'll just remove the brackets because they're just addition, no multiplication to make it harder. Now I color all A5s with orange and all A4s with pink or purple, whatever you want to do, and we can count them together. So we see that we have 2 fifth terms and 1 fourth term in the second equation, and we have 3 fifth terms and 2 fourth terms in the third equation. So we can plug in the numbers and calculate. First we have just 5 plus 3, then we have 2 times 5 plus 3, then we have 3 times 5 plus 2 times 3. We get 8, 13, and 21, which are the second part of the answer to this question. So the answer being Fibonacci sequence, with the next 3 terms being 8, 13, and 21. Next up, solve the arithmetic sequences for the nth term. In this case, n is 20. Since we know that it's arithmetic, we can calculate the difference, which is 3. Now we get the equation and just fill in the numbers for n 20, difference 3, and first term 3. We solve the brackets and multiply them with 3, so we get 19 times 3 is 57, because 20 times 3 would be 60, minus 3 is 57. Then we add 3 again to it, and we get 60. So 20th term, it's 60. Next up is the B example. We have to get the 15th term if we have a descending or lowering sequence, or whatever the word is, 10, 8, and 6. So the difference is minus 2. We paste the formula with the first term with n and the difference. We get 14 times minus 2, which is 10 minus 28, which is minus 18, being the 15th term. Next up is geometric sequence, where we have to get the 7th term in a sequence of 1, 2, 4. So here the ratio is 2. Paste the correct numbers into the correct spots in their equation or expression. We calculate it 2 to the power of 6, which is 64. Okay, next up is 6th term in the sequence of 243, 81, and 27. The ratio is 1/3, and we see that this example is similar to like the first task, but it's just slightly different. So we get the formula, we paste in the r and the n. 3 to the power of 5 is 243, which is what I checked up already, and 243 divided by 243 is 1. So the 6th term is 1. Okay, this one is slightly harder because it's a mixed challenge. So we have to do something we haven't really done before, or exactly, but we did get enough knowledge to solve it, as I said in the video. First, let's get the formula for the geometric, because we know that it's geometric. And we paste in the first term, and now let's think. We don't know what the ratio is, but we do have an equation with one variable, because we know that this is the second term, and we know that we can change the terms. For instance, we can calculate for the third term, so we will use the third term as 8, so an is 8 and n is 3, and we will try to isolate r, so we divide both sides by 2, and now we get this. Now, we have to take a square root of the equation to get r values. Of course, I will mark the root with a fraction exponent, as exponents work same as multiplication in a way, so if I want to get rid of this square, I can technically multiply or divide on an exponent level. So this is to the power of 1, this is to the power of 2. If I multiply by the power of 1/2, if that makes sense, hopefully. So you can look at the exponents if they're over the entire part of the equation. You can use them as levels or special domains, and their domains behave the same as multiplication or division in normal lines. So if this is to the power of 2 and this was to the power of 2, we could just take 1/2. So in the exponent level, we would multiply by 1/2, and that would cancel out both exponents, and we would just have the simple equation. Here, I'll just drag a root over it like we did in the equations. I'm not gonna complicate it much more. But this does cancel out the square here, and it gives us r to the power of 1. But we have this again. We have plus minus, since r is a variable, which we cannot know what it is, and it was squared, we have to add plus minus to the left side, because that's what we learned in the 2 videos ago or something, or last video one even. And now let's think about this logically. Can the ratio be negative or positive? Well, let's see. If we multiply 2 by 2, we get 4, and if we multiply again, we get 8. Okay, so it's definitely plus 2. But what about minus 2? If we have 2 times minus 2 is minus 4, times minus 2, oh, that's 8. Okay, so we have 2 solutions. Now, if you remember... No, I didn't mention that in the video. Of course I didn't. Well, if a sequence is geometric or something, it does not mean that it cannot be alternating at the same time. So it can be both alternating and geometric because it gets alternation from the negative ratio or the negative difference. At the same time, it's geometric because that factor is constant. So it's always multiplied by the same, sort of same factor in the formula. But yeah, anyway, the answer is plus minus 2, and it's both geometric and alternating sequence. Now, for the B part, we have 3 pieces of information. First term is 4, that the nth term is 3 greater than the previous one, and that we need 10th term. So let's rewrite this information in a way that's easier to be understood or a bit more clear. So what nth term being 3 more than its previous term basically means is that, what, am I dumb? This is supposed to be D. Fair enough. This is the difference. Ignore the R. It's supposed to be D. But yes, so we have first term, we have the difference, we have the n. So we can just paste that all in the equation. So first term plus n minus 1 times 3. We get 4 plus 9 times 3, which is 4 plus 27, which gives us 31. That's it for the mini test. Hopefully everything went well, and yes, if you didn't, you can always ask questions in the comments. I'm happy to clarify them. I do apologize for certain spelling mistakes I had in the PowerPoints in the video and the mini test. I guess I was just too sleep deprived to notice them. Or dehydrated and I was dizzy, I don't know. Anyway, thank you so much for tuning into the mini test solving. Hope you have a good day, hope everything went well, and see you next time. Have a good day. Bye.